Hey guys, Dr. Cadell here. This is the kinetics experiment. Now the general idea here is that we're going to study this reaction right here, the oxidation reduction reaction between iodide ion and iron 3. What happens is the iodide ion is oxidized and the iron 3 ion is reduced to produce iodine and iron 2. We're going to monitor the progress of this reaction by measuring basically the concentration of the iodine that appears. This has color, nothing else does. So the idea is that you're going to, once you finish the experiment, be able to calculate the order of the reaction with respect to iron 3 chloride, iron 3, and the order of the reaction with respect to the iodide or the potassium iodide. So the way we do this is just like we did in the homework. We're going to measure the rate of this reaction under different conditions, that is, different initial concentrations of the iron 3 chloride and the potassium iodide. And so let's say the first reaction, that's the rate of reaction under conditions 1. And that's equal to the rate law, the rate constant times the concentration, the initial concentration of the iron 3 chloride to its power. This is the first concentration of potassium iodide to its power, the order, right? And then rate 2, same thing on the bottom. Now, let's say in the first two trials, we keep the concentration of the iron 3 chloride the same. That's the way we set it up. Because it's the same rate constant, the K's cancel, the iron 3 chlorides cancel, and now we have the ratio of the rate under conditions 1 to 2 is equal to the ratio of the concentrations. This is not a 2, this is a y. And we're able to solve this equation for y. That gives us the order of the reaction with respect to potassium iodide. Pick two different reactions, and we can cancel out the concentration of potassium iodide and get the order of the reaction with respect to the iron 3 chloride the same way. Once you know the order of the reaction with respect to each of the reactants, the iron 3 and the iodide, our x and the y, then we're able to plug into a rate law, knowing the rate, solve for the rate constant. So you guys are going to do all that when you do your calculations. Now, during the experiment, we have it set up like this. So for our first trial, we're going to have 1.5 milliliters of our stock iron 3 chloride solution, 1.5 milliliters of our stock potassium iodide solution, and no water. And we'll do that reaction. We'll be able to get the initial rate, which I'll show you on the computer in just a few minutes. Then we're going to do the second trial, where we have 1.5 mils of the iron 3 chloride, stock solution, 0.75 mils of the stock potassium iodide, and now to keep the total volume the same, we're going to add 0.75 milliliters of DI water. And then we go through and we do each of the trials that way. The last trial, the sixth trial, that's the same volumes and concentrations as our first trial. The difference, guys, is that in trial 6, we're going to change the temperature by putting our reactants into an ice bath. What that does is that gives us two different temperatures so that we can use the Arrhenius equation and solve for the activation energy for this reaction. And let's go get started. All right, guys, so the first thing we're going to have to do is prepare our stock solutions. Now at home, you're going to have calculated how many grams of iron 3 chloride hexahydrate, it's important you include the waters in there, how much you're going to need to make 100 milliliters of about 0.02 molar iron 3 chloride solution. Same thing for the potassium iodide. You should calculate at home about how many grams of this you need to make about 0.02 molar 100 mils potassium iodide solution. Real quick, one word about this. This right here is the hydrate. This is iron 3 chloride hexahydrate. So when we weigh it out, we need to know the mass of the hydrate that we need. However, guys, once we put this into solution, then everything dissolves, breaks apart, the water molecules go off, and they're with the other water molecules. It's the iron 3 ion is the only thing we care about. So, I've done the calculations myself. So, to weigh out the iron 3 chloride, you take a weigh boat, place it on the balance, close the door, tear the balance. It says 0 with the empty weigh boat, take it out, because we never weigh anything directly on the balance. Take my iron 3 chloride. Guess about how much it's going to take. See how much that is. And it's too much. So take some out. Can't put it back into the container, so I'm going to have to put it somewhere else. Still a little bit too much. And close enough. So you're going to get your own numbers. Everybody's going to have a different mass of iron 3 chloride, hexahydrate, and potassium iodide. And so that means your concentrations are all going to be different, right? You calculate it. But I've got mine. I wrote that number. That goes in my data table. 3 past the decimal, little g for grams. I'll set that aside. Now I'm going to do the same thing for the potassium iodide. Again, I already calculated about how much I need. Place an empty wave out in the balance, tear it out, take it out, add some potassium iodide. This is not a hydrate, this is just straight potassium iodide. And close enough. So I got lucky with that one. All right, so now guys, we've got our potassium iodide and iron 3 chloride hexahydrate weighed out. I have 2 100 milliliter volumetric flasks. One I labeled iron 3 chloride, one I labeled potassium iodide. Iron 3 chloride, take the iron 3 chloride hexahydrate that I weighed out, transfer it to the volumetric flask. Now, there's some still sticking to the weigh boat. So what I do is I take some water, DI water in the wash bottle, and just rinse it off as best as I can. And that's going to take a couple times. We're going to add water to this anyway, so it doesn't matter. All right, it's good. So I got it all out. Set that aside. Now, we're going to add 1 molar hydrochloric acid to this. All this does, guys, this is not involved in the reaction at all. What the hydrochloric acid does is it helps to dissolve the iron 3 chloride, because it's pretty hard to dissolve this in just water. So what I've done is I poured 1 molar hydrochloric acid into this beaker. I'm going to use a graduated cylinder to measure about 10 mils. The actual volume doesn't really matter. It's just somewhere around there. So I've got about 10 milliliters of 1 molar hydrochloric. Add that to my volumetric flask. Put the stopper in, give it a little swirl, let it start dissolving. Now I'm going to add some deionized water. And what I'm going to do, as always, is there's a mark, I don't know if you can see it, on the neck. My goal is to bring the bottom of the meniscus just to the top of that line. So fill it up, about that far. Give it a swirl. Let it start dissolving. The hydrochloric acid works pretty well. There's still a few chunks in there, but they'll get dissolved. So now, be a little more careful. I need that meniscus just touching the top of that line. There we go. Put the stopper in, give it another little shake, set that aside, and do the same thing with the potassium iodide. We don't need the hydrochloric acid for this because this dissolves easily by itself. So there's my potassium iodide that I weighed out. And this doesn't stick as much as the iron 3 chloride does either. I pretty much got it all out, but just to be sure, I'm going to rinse it off with the DI water also. and then fill it up most of the way with DI. Once more, my goal is to get the bottom of that meniscus just touching the top of that line. First, looks like it's all dissolved already. This dissolves really easily, this stuff. So there's my line. There we go. All right, so this is my stock solution: potassium iodide, iron 3 chloride. Now I have 3 large test tubes, each labeled. One says iron 3 chloride, one says potassium iodide, the other says water. So I'm going to fill them up. These are just so because it's easier to transfer from these. I'm going to take my iron 3 chloride, which is all dissolved now, fill the test tube with iron 3 chloride on it, about halfway. This is where I'm going to be getting my solutions from as I do the experiment. And water. So I also have some plastic transfer pipettes, 3 milliliter pipettes, each labeled, one with iron 3 chloride, one with potassium iodide, as potassium iodide, and one is water. And I have 3 1 milliliter transfer pipettes labeled the same way. This is how I'm going to transfer my stock solution into my cuvette. This is a cuvette. This is where the reaction is going to occur. This is our colorimeter. It's basically a spectrometer that's going to measure the progress of the reaction for us along with the computer. So now we're ready to run the reaction. We're going to run the first trial where we have 1.5 milliliters of stock iron 3 chloride, 1.5 milliliters of potassium iodide. We're going to use Logger Pro on this computer to measure the initial rate of the reaction by measuring the absorbance of the iodine that appears. So if we know how fast the iodine is appearing, this gives us a measure of the rate of the reaction. To do that, okay, the colorimeter, we have to make sure we set the wavelength to 430 nanometers. So we just arrow over until it says 430. We have to calibrate it. To calibrate it, just open it up, take our cuvette, fill it up to that mark with deionized water. And whenever you guys are using a cuvette and a spectrometer like this, you want to make sure that you clean off the sides of it really well. Pop that in there, close the door, press the cal button. When that red light stops flashing, it's calibrated, and we don't ever have to do that again, ever. So it's calibrated. Take this out, dump out the water. Now, I'm going to use the same cuvette for each trial. So I don't know if you can see, but there's some water droplets in here. I want to make sure that I dry that out because that's going to dilute my solution that I put in there, and the concentration will not be what I think it is for my calculation. So between each run, I just need to make sure I get that pretty dry. So that's good. So ready for our first run. I have Logger Pro set up so that it has absorbance on the y-axis, time on the x-axis. Cuvette's in there, empty. First thing I'm going to do is take my 3 milliliter transfer pipette that says potassium iodide and pull up 1.5 milliliters of potassium iodide stock solution from my test tube. and put it in there, potassium iodide first. The reaction will not start, guys, until I add all the reactants. So I'm going to add the iron 3 chloride last. Once I add that, that's when it starts. One and a half mils of potassium iodide. Now, what I'm going to do is I'm going to press start on Logger Pro. So it's going to start recording, but I don't care. I'm going to ignore everything that happens until I add my iron 3 chloride. This way I catch the very beginning. So now I'm going to press start. And it's recording, but I don't care yet. Now I'm going to add 1.5 mils of iron 3 chloride. Remember, this is trial 1. The volumes change as we go through the different trials. Put it in there, close it, and now it's going. So now you can see that the absorbance is starting to rise. Okay, the slope of that line, the tangent of that line, the slope of the tangent of that line is the initial rate. So I'm going to let it go for about 100 seconds or so right here. Once it does, it's really nice. We can use Logger Pro to get the slope of the tangent line at the very beginning. And that's our initial rate. So again, we're ignoring all this stuff in the beginning because that's before I added the iron 3 chloride. We didn't see this line until the reaction started, which is when I added the iron 3 chloride. And eventually, guys, it's going to flatten out. Remember, if it flattens out, that means that the rate is not changing. We're at equilibrium. But that's not what this experiment is. All right, so there we are. We're at about 100 seconds, so I'm going to stop it. Now I just need to get one number, and that is the slope of the tangent. So now to get the slope of the tangent at the beginning, to give us our rate, I click on Analyze, Tangent, and this little box appears right up there. And it gives me the slope, that red number in the back. So what I do is I move my cursor. Can you guys see that black line right there on top of the red line? I want to get that right at the very beginning of my curve. So right there, that slope is going to be my initial rate. So 0.0134. Everybody's going to have different slopes because they have different concentrations. And that's basically it. We're going to do that same procedure, only with different volumes of iron 3 chloride and potassium iodide, using water if we need to bring the volume up to the same volume. 4 more trials, and then we do that one last trial with the same volumes as we just did, except that we change the temperature by putting the reactants into an ice bath first. And that's pretty much it.